All right, we are going to talk about similar figures today. And I have the worksheet here for you to fill out as I kind of go through this, and we're going to fill in some words here first. So, similar figures have the same shape, okay, same shape, but not necessarily the same size. So if we look down here at these figures down here, they are similar. We can see that they're both right triangles, so they have the same shape, but they don't have the same size because clearly this one is bigger than this one, and we'll number these here. We'll call this figure A and this figure B, and figure A is clearly bigger than figure B, but because they're both right triangles, they are similar. Now, the symbol looks like this, so it's kind of like an equal sign, but it's kind of wavy. It means similar to. A scale drawing is an enlarged or reduced drawing that is similar to the actual object or place. Now, the reason we call it a scale drawing and say that it's similar is because it's going to have the same size and represent the same dimensions and things, but maybe I blow it up. So like a map is similar to what you would see in real life, but obviously we need it smaller so that we can fit it on a piece of paper. We will talk a little bit more about scale drawings later, so we'll kind of keep that in the back burner for now. In similar triangles, corresponding angles are congruent and corresponding sides are proportional. Now, congruent. Congruent means the same. So if I look at my two triangles down here, I said that they were similar, so corresponding angles are congruent, the same. So notice that this triangle has a right angle and this one has a right angle. A right angle is 90 degrees. And this one is 90 degrees. So even though this triangle is smaller than the first triangle, I still have a 90-degree angle there. That doesn't change. Just because I make the triangle bigger or smaller, my angles are still going to end up being the same. So maybe this one here is 40 degrees. That means that this one is 40 degrees. And then if this one is 50 degrees, then this one is 50 degrees. So my angles are all the same in similar figures. Okay, I mean, you can kind of think about it like this. If I draw a triangle like this, and I say that this right here is 75 degrees, or an angle, and then get another color. Let's say I decide to make this line a little longer and this a little longer. Just because I made the sides longer doesn't change the angle being 75 degrees. So, similar triangles, and this is true for rectangles as well. They have corresponding angles are congruent, but the corresponding sides, they're not congruent. Now, congruent means the same. And I can tell by looking here that this is not the same length as this. One's longer than the other. But they are proportional. And that's important because we've talked about proportions and how we can use proportions to solve things. So it's really important to remember that they're proportional. So find the figures in each pair are similar. Find the missing length. So I want to find this length right here. And since they're proportional, I can make a proportion. So I'm going to start by making like a chart here, kind of like a tic-tac-toe board. And there are three things. We have a ratio, and remember a ratio is a comparison of two things. Then we have triangle A and triangle B. So we'll call this one A and this one B. Now we have to pick two sets of corresponding sides. So we're going to do a leg and leg 1 and leg 2. I don't have a better name for them. Right? So now all I need to do is just fill in my boxes here. So on triangle A, leg 1. So let's call this leg 1. So triangle A, leg 1 is 5. On triangle B, leg 1 is X. We don't know that one. Triangle 2, leg 2 on triangle A is 8. And leg 2 on triangle B is 5. Now, once I have all of this in my box, I can use this to help me set up my proportion. So I have 5 over X is equal to 8 over 5. And now to solve a proportion, we cross multiply. So X times 8 is 8X, and 5 times 5 is 25. Divide both sides by 8. And 25 divided by 8. Well, that is not going to go in nicely. But that's okay. We have a calculator. So we're going to say it is 3.125. And it did tell us that it was feet. So I can put the feet on there. 3.125 feet is what our X is. Okay, now the next one on down there is rectangles. And rectangles are similar figures as well. Now, all of my angles in a rectangle are 90-degree angles, so I know those are all going to be the same. So I'm going to set up my little box here, my ratio. Boy, that's just some really bad writing there. I'm going to try typing it so you can see it better. Okay, so ratio, and then we have box A, and oops, box B, okay. Now, with a rectangle, we usually call things length and width. So we'll call this length and we'll call this width. We'll call this length, we'll call this width. So up here I can have my length and my width. Right? So my length for box A, oops, I gotta name my boxes. Oops. A and B. Okay, so my length for box A is 120. The length for box B is X. The length for, or the width for box A is 18. And the width for box B is 12. Okay, so I can set up my proportion here. Is 120 over X. And that's equal to 18 over 12. I think you have more more space on yours to write, so that's good. So I'm just going to write over top of this here. So I have 18x equals, when I go to cross multiply, 1,440 divided by 18, and x equals 80. And that's my answer. So our little checkerboard thing here can be really useful for us. Help us make sure we get everything all lined up and in the right place. All right, now let's look at some of these word problems. Now, it's talking about two rectangles that are similar, so that's good. So we know we can set up a proportion. And I'm going to find a missing side. So I'm going to just jump right to making my little box here. I got rectangle A and B. I'm going to have length and I'm going to have width. So here's my first one. We'll call that one A, and then the second one we'll call B. So the length of A is 15 long, and the width of A is 4. The second one is 9 wide, so 9 goes here because that's the W, I want the wide. Find the length, and they want me to find X. So it doesn't matter what order they give it to me, and if I have my box here, I can get everything put in the right place. All right, so let's write our proportion. 15 over X is equal to 4 over 9. Cross multiply, and I get 4X is equal to 9 times 15, which is 135. Divide both sides by 4, and X equals 33.75. Okay? All right, now we're going to do another one. And why don't you go ahead and pause the video right now and work this one out and see if you can figure out what the answer is to number 8, the width. Oh no, I'm sorry. You can't do this one. I'm going to show you how to set the box up, but we can't solve this. Let's do that though. Let's set up our box because it is interesting. So we're going to have triangle A and B again, and we're going to have length and width. But this is one that's kind of like some of the stuff we've been doing where it has this, you know, increased stuff. So one of them is 5 by 12, right? So I can go ahead and say that triangle A is length of 12 and a width of 5. Usually our length is bigger. Okay, then it tells me that the longer side of the second rectangle is, so remember is means equals, so they're getting ready to tell us what it is. It is 8 centimeters greater than twice the short side. Oh my goodness, that's a lot, but that's okay because we can break this down. So I know it's bigger than the short side, which is the width, right? So I'm going to make the width X. Now 8 greater than would be 8 plus twice 2 times X, or the width, which is X, is X. So that's how I would fill my box in. So then when I want to go and write my proportion, I'm going to have 12 over 8 plus 2X is equal to 5 over X. And see, now we've got all these X's, and we could do cross multiplying and we could solve it, but that's a little bit more than what we're going to do right now, so we will just stop right there on that particular problem. Okay, but we are going to look at the ones back here. Now, number 9 is a scale of a map, and we're going to talk about that in a couple of days, so we'll just skip that one for now. But this one I love. Tree. I need a tree. So let me draw a tree here. Here's my tree. And it says that my tree is casting a shadow. So here's my tree's shadow. And it says that the shadow is 7.5 feet long. Okay, 7.5. Then I have a person or a lady. So we'll draw my little person here. Here's my person. My lady. And it says that this woman is 5 feet tall. Okay, so I'm going to give her a height here. She's 5 feet tall. And she also casts a shadow. Oh, here's her shadow. It's not a brilliant shadow, but you know, hey, it'll work. And her shadow is 3 feet long. So the question is, how tall is the tree? Well, that seems to me like it has nothing to do with each other, right? But what this makes is the tree and its shadow make a triangle. And so does the girl and her shadow. And what we have are 2 proportional and similar triangles. So I can set up a proportion. So I'm going to draw my little box. Now this time I'm going to be comparing my ratio, what I'm going to compare. I'm going to compare the girl to the tree. Okay? And I'm going to compare the height to the shadow. All right. So now let's fill in our stuff. The girl's height is 5. The tree's height is x because we don't know. The girl's shadow is 3, and the tree's shadow is 7.5. And now we can write our proportion. 5 over x is equal to 3 over 7.5. Cross multiply. 3x is equal to 5 times 7.5, which is 37.5. Divide both sides by 3, and x is 12.5. So how tall is the tree? 12.5 feet. And that's it. That's how we can use our similar figures to help us find different missing measurements.